Okay, let's sit down. Mr. Stone's eating, so he'll be uncharacteristically quiet today. How'd y'all like that exercise? How many of you caught the scale error? Sorry? Well, why don't you point them out to us? Silence.
I think it was an error when it was asking for the slope, and then it had in parentheses in car.
That could be. I don't know. M-car is a slope, but
There were lots of times
I can't get good help. But you know what? You're learning, aren't you? Maybe we should pass it through you before we hand it out. I'm wondering if you'd make a better clerk than an engineer. There ain't no answer key. You ought to know that. So Dylan asked me on Wednesday, he says, how come there's so many of these quizzes with flowers drawn on them? I said, that might be my fault, because I told you you could draw a flower on it if you didn't know the answer. Anything else before we start? Yes, ma'am. Nope, just scratching your head. This little body motion there. Oh, man. Okay. Nobody else. I was tormented. I was going to send you an email and say, it's time to, show me what you're really made of. We got another blue one today. Pretty soon we're going to change the yellow, though. We're going to run out of blue paper. Is that going to make a difference to you, Mr. Stone? On yellow? You like yellow? Yeah. I wasn't happy with how the quiz turned out. I mean, I worked it for you twice, and it's even written on the board here. But, whatever. My personal favorite were the ones that kind of went up and down like a sine wave. And, of course, where's Guillermo? See here? Yeah, the sawtooth was a nice effect, too. I like that. And for all of you that just put a flower on the quiz, that's good. Why me? Okay, today we're going to talk about material balance. What has Dr. Momora taught you about material balance? Why do I even try? Mr. Cottle? You like my shirt? Here, I'll give you a little more. Okay. It's Formal Friday. Apparently I've set off a trend because I don't even know what his title is. I guess the sub-executive director at SPE sent me a note today saying he was wearing these to the office today. So it's good, We can all revert back to our naughty little boy self. Except you never were, right? So tell me what you've learned so far about material balance. What goes out must be accounted for. Kind of like a bank account. Only in material balance we don't really put things back in, do we? Except when we inject water or gas, or when God injects water, not usually gas, right? What do we call it when God injects water, people? Water influx or water encroachment. And if you look in the SPE library and you type the words water influx and water encroachment, I did it once, and I got something like 730 references. So you can tell this horse has been beaten to death, taken out of its grave, beaten some more, and then periodically beaten again. Why is there so much emphasis put on water influx? This is a trick question, so somebody who likes tricks, give me an answer. Your name is Barack? Okay, Barack. Why is water influx such a focus?
It's a tough problem.
It's
a tough problem.
I don't know. What should we give him for that?
An A.
An A? and a foot in the... Anybody else want to help out with this? Yes, sir.
I think the water impact is important here as it can damage the work and it can hurt to bring the oil to the surface also.
Ordinarily I should be like soft and touchy and try to help you along. But what I'm wanting you to do right now is just take a little nap, okay? Just lay your head right down and we'll get back with you. Oh, my favorite student, Mr. Goins. I see McDonald's in your future, please.
It's because it makes it hard to determine the ultimate recovery.
Ooh, hadn't seen that one coming, kind of like a boomerang. Your usual idiocy defied me. This time you came straight ahead from behind, okay?
Does that mean I got it right?
Not exactly, no. So water influx is what, Mr. Cottle? It's a volume, right? It's it's actually a mass, but we don't measure mass. And it's stuff that's coming in, right? This is important because you're going to talk about water influx in 323, and I'm going to tell you a little secret. Nobody knows the answer. That's why there's so many papers on water influx. That's why there's so many theories on water influx, because nobody measures water influx. How would you measure water influx, Mr. Beard? You'd say, "Dear God, I need to know how much water came in the reservoir from your bank account." And what do you think is going to happen? It's going to be like all those Dear Santa and Dear Tooth Fairy letters, right? Yeah. Only people are like Marmina here are going to give you an equation for water influx, okay? But there's going to be something kind of suspicious about that equation. You know what's going to be suspicious about that equation? You don't know whether it's right or it's wrong. But Marmina here is going to take your money just the same. He's got that consultant look, That's what a consultant does, right? They take money for things they don't know how to do. And then they have three possibilities. Like in the Terminator movie, they pick one of them. Okay. Oh, y'all are too young. All right, so we'll come back and talk about water influx in just a minute. But what I want you to realize is every time you see the symbol WE, which is water influx or water encroachment, a bell should go off in your head because you don't know what WE is. And we'll talk about that some more. Are there any other problems that we're going to have to be aware of with water influx? Mr. Clayton, you're playing tennis up there. You're not looking at me. Help me out here. What other kinds of problems are we having with water influx? Mr. Bueno, you got to know what came out. So you're going to measure the oil, and you're going to measure the gas, and you're going to measure the water. What's this? That's the Iranian, I don't know, okay? Is it yes or is it no?
No.
Is it no what? Is it no on the head shake or no on the measurement or what? You're driving me crazy.
No on the measurement.
No on the is that true? Oh, you're awake now. Do we measure the oil?
Oil volume? You can measure it.
Do we measure the oil volume? Do you remember the movie Deer Hunter?
No.
Yeah. I want you to watch it tonight when they're in a Vietnamese prison camp and the guy won't put the pistol to his head.
If you can lend it to me, I will watch it.
Yeah. Look it up on YouTube. I'm sure it's there. Do we measure the oil volume? Why? Because that's what we sell. Now, do we measure the water volume?
No. I said we can measure it.
We can. That's not what I said. I said, do we? That implies a positive, not a possibility, okay? But a definite likelihood. Do we measure water? What? Louder.
Productive water.
Produced water. Do we? Do you measure it in Kazakhstan? Do you measure it in South Texas?
I wouldn't. No.
You wish?
No.
Do you measure it in Nigeria, is it?
No.
Do we measure it in South Texas?
I don't think so.
I want you to take your hand, because I can't touch him, okay? And I want you to approach critical velocity. Remove your pencil, okay? Are you required in the state of Texas to measure water? Yes or no? Yes. Now, is it accurate? Why? Because it's like in Kazakhstan. Today we produce 1 billion tons of water. Oh, sorry. Is that what you're saying? Okay. Is that the same way things work on oil? Yeah? All right, so we've got this down. We have to have measure. Now, here's the big one. Everybody ready? We measure volume, right? Because that's what we're going to count. We're going to count molecules. I know it seems a little trivial, but here's the big one. Ready, Mr. Cottle? Behind door number 1. What is it? What else do we have to measure? Starts with E, ends with P. No, that's my dyslexia. Sorry. What is it?
Pressure.
Pressure. Okay. Where do we have to measure pressure? No. I'm going to start rolling this up, okay? At the surface. I'm going to turn this into dust. Where in the reservoir? Technically. Everywhere. Why? Because you remember when you had Dr. Barefet for 310 and you had that cell thingy with the fluid in it? Or did you have Dr. McVeigh? Or McCain, sorry. You had Dr. Barefet, okay.
Yeah.
So you had a cell and you expanded it and some gas came out of solution, then you screwed it back in. Oh, this is all.
Online.
Yeah, I was going to say it. It's like it could have been done in India or something, right? You never saw anything. Yeah, that's right. Did you get my cartoon about that? Yeah, that's a pretty good cartoon, actually. It's after the internet, but I won't belabor it now. Okay, so you know that you've got to measure the pressure in the cell, because what does the pressure represent? Energy. Okay, very good. And how do we relate that? Okay. I don't think I was ready for him. He's not really right, but he's not really wrong. So let's look at the equations and make sure. But if we have a compressible fluid, we have a law for isothermal compressibility, right? And that law relates volume and pressure. So we're going to integrate that law and get a relationship for volume in terms of pressure. So we have to have a relationship for volume, we have to have information for volume or volume change. We have to have information for pressure. All right, we're on our way. Let's change the slide. Oop, notes. Okay. Dylan, you want to come down here and read this to the class since this is your favorite line? Oh, you want me to read it? It seems no longer fashionable in the minds of those moronic managers to apply the concept of material balance to oil fields or gas fields, the belief being that it has now been superseded by the application of the more modern technique of reservoir simulation. Do we all feel better now? Okay. Acceptance of this idea has been a tragedy of Greek proportions and has robbed engineers of their most powerful tool for investigating reservoirs and understanding their performance, rather than imposing their wills upon them, as is often the case when applying numerical simulation directly in history matching. What is this author saying, Ms. Fletcher?
That instead of figuring out ourselves on the reservoir,
Instead of analyzing the problem, we're modeling it. Does everyone understand what he's saying? Instead of looking at the problem in the context of what it's telling you, you're using a simulator in order to get an answer. Okay, so let's give an analogy to this. You're not going to drive today. You're going to use your computer, I suppose, and you're going to do what it tells you in terms of driving. How far are you going to get? About 3 feet before you back into a tree or run over some kid or something like that, right? But we've readily accepted that we can use simulation unabated. We can do whatever we want with it. Now, I know this is Dr. McVeigh's area of expertise, and he is going to emphasize how wrong I am that we should actually listen to the reservoir and utilize the information from it to characterize it, as will Dr. Dattagupta. But the simple truth is, this is the only real data you have. Everything else is model-based. And we all know, right, Marmina, that the difference between model and reality can be very severe. For example, when you're on eHarmony, and I picked a family channel, I want that noted. You know, it's not really the same as reality, huh? Because after you get to know them, you find out they're really not very nice, and they kind of got a lump where their head's bigger on one side than the other, you know, that kind of thing. Yeah? Okay. And their favorite dish is liver and garlic or something like that. You know, reality sets in. And that's why I prefer to analyze the reservoir response rather than have the model tell me what it is. Wilhelm, care to comment? Is a model in the hands of an expert a good thing? Sometimes. Why sometimes? See, you guys expected him and I to have a conversation where we would say that you have to be an expert in order to use a reservoir model. But you don't have to be an expert. In fact, I'd rather you not be an expert. Why, Dilhan? Because then you're not going to immediately jump to the conclusion of the last problem you solved, impose that on it, and say, where's my money? You're going to go through systematically and evaluate all the data that you put into the simulator. Every job application you see with the word reservoir engineer in it either has economic evaluation, which is like idiot work, or reservoir simulation, which is idiot work, okay? I know it's being recorded. I'm sure I'll hear from you later on today. So, you have to take everything that came into the reservoir, comes out of the reservoir, and is generated in the reservoir. What could be generated in the reservoir? Gas, okay? We need the average reservoir pressure. How are we going to get that? Zaniro? My favorite reservoir is ye old kidney bean, okay? I have well number 1, well number 2, well number 3, right?
So a statistical average or something like that. You know.
Reach around and just clunk him like that, okay? Yeah. All right. This is measurements, okay? We're going to measure everything. So we're going to perform that pressure drawdown and build-up thingy. Here's a pressure drawdown. Here's a pressure build-up. That's in well 1 as a function of time. That doesn't look good. No offense, black on black. Okay, so PW. I didn't mean nothing bad. I was making a point. Okay, so PW. And then it builds up. Oh, I got to go back. Well, I go to red. Okay. PW. All right. So this one is going to build up to a certain P bar. That'll be P bar in well 1. This one will be P bar in well 2. And this one will be P bar in well 3. Why does that happen, Mr. Z? Because each one of them drains a different volume. They're all in communication, but there'll be some fantasy line in between here where what happens? A particle of fluid decides whether he's going to go to that well or that well. And if he can't decide, what's he going to do, Mr. Cottle? He's not going to move. So that's a quasi no-flow boundary, okay? It does change with time, okay? So then we can have another one like this. And Marmina, we're going to have flux into this case, right? Flux into this case, right? Flux into this case, right? Nathan, you ready? For an A in this course, tell me the definition, the rigorous definition of average reservoir pressure.
I'll leave that with you.
Okay, this is A1, A2, and A3. It would be P bar total, if you want to call it that, would be P1, A1, plus P2, A2, plus P3, A3, all divided by A1 plus A2 plus A3. Is that correct, Dilhan? Not exactly, right? Because it's supposed to be pore volume. See, I had a secret trap door built in just in case you would have gotten it right. Okay? So how are we going to estimate the drainage area of each well, Mr. Stone? Mr. Stone, you're going to swallow that toothpick, and it ain't going to come out, if you know what I mean. All right? Nasty habit, son. All right, so you said you're going to estimate it? Model it. Mr. Stone, lay your head down. We're not going to model anything. Now, how are we going to measure this, Mr. Goins? We can run 3 different pressure buildup tests and estimate P bar for each case, right? That part physically makes sense. How are we going to get the drainage area for each compartment? Anybody? Dilhan? It ain't going to happen, is it? Can't do it. So can we have a surrogate for area? What's a surrogate for the drainage area? See, y'all got all quiet because this is like Fat Albert. Y'all might learn something before it's done. All right. So the rigorous P bar is going to be the summation. I'm sorry for doing funny symbols, but that'll be P bar sub I, VP of I. Sorry for my handwriting. And then summation of VP of I, right? That would be the definition of P bar. But we don't know how to estimate how much each one touched. Technically, it's an integral over the whole thing, but that's okay. So what can you use as a surrogate for the pore volume? Tyler? Sure you do. You were going to say that P bar is approximately the summation of P bar of I and then NP, the oil produced, right, or the fluids produced for each one, and then the summation NP of I, right? So if we take the production from each well, multiply by the pressure for that well, and then divide by the total, that should give us an average pressure. It's a little trick. Sorry?
The production measured over what time period?
Well, you'd have columns, right? And you'd have well 1, well 2, and here you'll have pressure, well, I assume, and then you'd have NP, pressure, and NP, and of course time. So you'd have that spreadsheet thingy that you guys all know how to use, and then you just take it from there. Okay? Now technically, you're going to need to know the thing's not going to be fully populated because you're not going to have a lot of estimates of pressure. And that's the missing link. I know we spent too much time talking about this, but the reason you cannot perform material balance is because you don't have the pressure data. Now, the state of Texas requires what, Mr. Cottle? By the end of the semester, I'm going to have a collar on you, You ready? What does the state of Texas require of every gas well in the state? More detail. More detail. You must test a gas well in the state of Texas once a year, correct? And you must have a pressure measurement and a rate measurement, right? But of course, since there are several 100,000 of these, people just walk up. Well, today the production is... That happens, right? But technically, they're supposed to do this. And when you go on to the production database from IHS or Lassiter or HPDI, underneath it there's something called well tests. Doesn't mean pressure transient test, it means the annual well test. And if you look in Texas, there's usually, maybe not every year, but there's usually some sort of information in there with a pressure and a rate. It may be total garbage, but something is reported to the state. What about in Montana? Nope. What about in Utah? I don't know. What about in Madagascar? Doesn't matter. It's not in the database, okay? So we need to be able to estimate the average reservoir pressure, and we need the rock and fluid properties. So the missing link, Marmina, is right here. You know the missing link? Okay, so we can't do material balance. So when Dr. Momora says to you, today we're going to solve a material balance problem, you're all going to get up and walk out, right? He says, no, I'm not going to do that. But you should. You should say, Blasingame says we can't do this because there's no pressure data. And then what's he going to do? He's going to try to kill me, but he's going to have another heart attack. Well, you know. It's a joke, people. Dylan, do you think they're going to understand that we're not going to have average reservoir pressure in general? And otherwise, what are they going to do? They're going to walk up to the well file, they're going to take whatever pressure data is in there, and they're going to try to perform material balance, and it's going to be horrific. Where in this world do people take annual pressure measurements on every well? Saudi. Everywhere in the United States, generally speaking, people take an annual test on their gas wells. But generally speaking, depends on state and local reporting and all that. You may never see the data. Oil wells, forget it. So where are you going to see a pressure data set for an oil well? You're going to see it in Kazakhstan? Probably not. Maybe. Or we all know, today. All right. That's terrible. I shouldn't joke about that. Now, when we start talking about gas, we can perform gas material balance, but I want you to recognize the weak link is still going to be pressure, because we still have to take all those well data and combine it into an average reservoir pressure. Now, if it's the only well in the field, that's pretty good, right? Or if there's only a few wells, that's pretty good. But if there are dozens of wells, what are you going to do? Sorry? You're going to punt? Is that what you said? Dilhan, what about that fancy software package that those Canadian guys wrote that allows you to put all the data from all your wells in there? And they do this for you, right? Yeah. So somewhere somebody may have a product that you can use, but you still better be very careful. Now, before we go into the slides, and I hope there's still time, let's talk again about abnormal pressure. Mr. Stone, can you give me an example of a time in your life when you've been abnormally pressured?
311, that's doing those laps.
Okay. Anyone else? Mr. Zanero?
Pretty much the same time.
Okay. Just wait till we get to 324. That's going to be fun, huh? The assignments start hitting. Yeah. Okay. So the abnormal pressure concept is not a new one for you. Whenever we start looking at the abnormal pressure cases, we're going to have to figure out a way to analyze them. Notice I used the word correctly. We're going to have to analyze. What about water drive? Why did I write always problematic? Ms. Lever, what's another word for problematic? Cheat. You're going to have to cheat. You're going to have to assume a reservoir model. You're going to have to assume some sort of influx constant, and then you're going to match the performance with that. But now you're assuming that all the deviation in the system comes from water influx. Is that likely? No. If I shove you guys over here, it won't affect them over there. So there could be a problem with that concept. Y'all don't tell Dr. Memora I want him to have a heart attack. I do not want that to happen. He's a friend of mine. Let's see. Okay, I think we'll talk about this. Let's just give them the quiz. They need the extra time. We'll cover this again on Monday.